All right, so let's get into completing the square. I'm going to talk a little bit about the main idea. It's kind of a process. We'll get some practice with that. I am going to make you do a couple of these before the homework problems. And we're going to have a couple more applications of this later. So completing the square is a process where I've conceptualized it as these 3 steps. And then once you've completed a square, there are various things you can do with that. I'll just use a specific example for that. And the whole idea behind completing the square is that there's a sort of an element of pattern recognition. That is if you have an x squared and then you have a constant times x, you can add and subtract a constant. And if you have just the right constant here, then those 3 things will look exactly like a perfect square. So let's just look at the overall pattern. Well, if we had something that was a perfect square, well, what kind of balance would you need between those 3 numbers? Well, first of all, notice that if there's no a on the inside, that's better. That a would complicate things. So let's just forget about that for now. So it's just if we have x plus h squared, then if it were a perfect square of the form x plus h squared, then we would get x squared, we get 2hx, and we would get h squared. And so as soon as we know that it's x plus h squared, there's only h in the picture. So these other 2, the x term and the constant term, have to be in some special kind of balance here. So how are they related to each other? Well, if I write it in terms of h, if it's x plus h squared, then the middle thing has to be 2hx, and the constant has to be h squared. Well, what's going to happen in particular problems is usually it's just this could be 4x, this could be 5x, this could be 17x, this could be the middle term. It's not going to be written with a 2 most of the time. That would be that's just like something you have to kind of think about it just a little bit differently. And well, what's the relationship between 2h and h squared? Well, if c is 2h, then what's the relationship? Well, to get from here to get what process gets me from this term to this one? Well, I divide it by 2 because I don't like the 2. So let's think of this c as being actually a 2h. Well, we have to divide by 2 and then we square the result. So that's the process. So you take the process that you take the coefficient, you have it, and then you square it, you get h squared. Take the c, have it, and you square it, you get c over 2 squared. So once you understand the process, you just apply the process to something that doesn't look like 2h. I've written it down as c here, so it's half and square is what you have to do with the middle term to get the constant. So the middle coefficient, half and square, gets you h squared. Middle coefficient, half and square, gets you the constant. Okay, so that was like a little theory crafting. That's kind of the very, very most important insight. How do we put the pieces together? It'll make a lot more sense when we put it all together. So let's do a couple examples. Let's warm up with one where a is equal to 1, so we don't have to worry about it. make the numbers kind of nice. Something like that. All right, so step one, there's nothing to do because a is 1. We factor out a 1 from the left-hand side. There's nothing to worry about. So we can go straight to step 2. And the whole idea is what's the magic constant, and here's so here's how I'm going to do it. So I'm going to leave a blank space here. And the idea is that we want, if we add just the right constant using the half and square rule, well, there's two ways of looking at it. We need a magic constant to make this piece that I put these dotted parentheses to conceptually group it one way. Okay, if I add a magic constant, then this piece is a perfect square, and this piece is just a constant. And I know what to do with a perfect square plus a constant equals 0. That's kind of nice. That's the whole point of the exercise. That's what's going to help us. And we just need to know what the magic constant is. Well, the magic constant is middle coefficient half that squared. So half that is 2, half squared, so we square the 2, we get 4. So if we add 4, we have to subtract 4 in order to keep it all balanced. And there's two ways of looking at it. One way of looking at it is I have the exact same thing, but I've added and subtracted 4. The other way of looking at it is, maybe I'll use green parentheses. So one way of looking at it is I've added and subtracted a 4, so it's exactly the same equation. But the other way of looking at it is the green parentheses is now a perfect square. And what is it? Well, that half is what is the constant of this perfect square. So it's x plus 2 squared minus 14 is equal to 0. So from here, it's looking pretty good. And then as a solution set, it's -2 plus the square root of 14, comma, -2 minus square root of 14 is the other one. And that's how you do it. All right, so what do we think here? So is this looking pretty good? Let me just reiterate what we did. We had something that it's a quadratic, and we look at this for a minute. It's like, oh, I don't think that wants to factor. It's not factoring as anything nice. So what do? We do this. Well, okay. So we make sure we have a 1 for a. If not, in some situations like this one, we could just divide everything by a. There's some situations where factoring is more useful, and I'm going to do it that way. But anyway, so we've got a 1 here. That's the first thing we need. We need to have a 1 in front of the x squared. And then to get a perfect square, then the middle term and the constant have to be in this perfect relationship. Well, what we do is we take the constant it's probably the wrong constant. We just put that on the side because it's still there. We still have to account for it, but we want to add the right constant and then subtract it as well. So everything we don't want goes outside. And we do this. So we take the middle term, the middle coefficient, which is 4, we have it to get 2, and then we square it to get 4. And so what do we get? We get x plus 2 squared is the good stuff. And then we got leftover constant of negative 14, and then that's easy to solve. Relatively easy. It's a lot easier than what we started with. And that's kind of it. So let's let me just change the numbers a little bit, and then let's do most, let's do the same thing. Let's not these are a little bit tricky. I don't want to jump straight to the general case just yet. Let's just change this to let's just change that to a 6 for now, and then that'll be there are too many 4s on the board. It's sometimes that the numbers, sometimes if you see the same number over and over again, it's a little bit hard to see what's what. This one, the numbers will be a little bit different, and that should make maybe a little bit more satisfying, make you more confident that you're seeing the general picture. Okay, so we've got, you're allowed to use colors as well if you think that this is a cool thing that helps you understand it. Well, the whole point is we want to have a perfect square, but if we add something, we have to subtract it as well. And well, we can't, the thing that we actually started with is still there. We haven't lost this negative 10 yet. That's also important. And what do we want? We want the green, the thing that's in the green brackets, it has to be a perfect square, which means we half of that 6 is 3, and then you square it, and that's if this green thing is x plus something or squared, then the constant had better be half the middle thing, that quantity squared. So we add 9 and we subtract 9. And then this green thing, what is it? It is that has to be not x plus 6 squared, because that would give us too many x's when we actually squared it out. If we actually square this out, it has to be the half. So if you put x plus 6, if you wrote this down, we'll go ahead and actually multiply it out. You'll get 12x, and that's not what we had the line before. Make sure that you really are getting exactly the same thing. So if you're unsure, every single step of the way, you can double check whether you've actually made a legal move or not. Like if you say that this is saying the same thing as this, then maybe you should check that maybe you should check that this thing squared really is that. Okay, what do you get? If you were to go off on a scrap paper and you multiply 2 copies of x plus 3, you really do get 6 x's, an x squared, and a 9. Don't take my word for it. Very famous words of wisdom. And that's what you get. So, all right, let's do 1 or 2 of these where there's an A in front. I'm going to do it a very specific way. The way I'm doing it is maybe there are some applications where you really want to do it the way that I'm doing it. For just finding the solutions to the equation, like what are the x values, it doesn't really matter as much which approach you use, but I'm going to deal with the A in a very specific manner. So let's do that. So step number 1 I haven't done yet. Is that what I want to use? Let's see. Yeah, that looks fine. All right. Yeah, let's say. Okay, so that's the equation. So we're solving this equation equal to 0. So what I said was this. If I want to factor out the a, well, there's this giant square bracket, and then everything inside the square bracket is going to be exactly the same process, but you do it all inside of here. So we factor out the a, and so let me make a little bit of space here. Well, so these, the usual trick, these are not divisible by -2, so we can make it divisible by -2, sort of. Well, it's going to be a fraction, but if we multiply and divide by -2, we can factor out the common factor. So if I include this -2 here, then I've got let me color this one green, the one that I'm factoring out. Maybe the one that I keep, maybe I'll color that one blue so you can doing different things with these. So this one I'm keeping, the green one I'm factoring out. And it's kind of like this. This one was already a part of the original problem, so we don't have to do anything. That's just the a. Let me just rewrite the original problem. So what we had was -2x squared minus 3x plus 7 equal to 0. Okay, so the first one already has a -2, and that's the one that we don't like, because completing the square, if there's something in front of the x squared, then x plus h squared is going to be something different that we don't like very much. So let's simplify it. The way we can pretend that it's not there is we factor it out, and then everything else changes when we factor out this -2. But this -2, if we factor it out all the way to the outside and then work with the inside, we'll be good to go. But we have to do something. So we don't have a -2 here, so we have to put one there. We didn't have a -2 there, so we had to put one there. And so these two are left over, so we get plus 3/2 x. This -2 has to be factored out. This -2 is factored out, but we still have, so the green one is factored out, but then that's equal to 0. So and at this step you can double check. If we were to distribute the -1/2 to each of these, we would get the original equation at the very top line. That's the goal here. So now when we get to more applications, like in the very next section, when you graph a quadratic function, this is going to be a helpful way of thinking about it, because basically if you complete the square and you don't change the function by, you could divide the whole thing by -2, but then the left hand side is, both sides are not the same quantity as what you started with. That's the downside. So I'm doing it this way because I haven't moved anything to the other side, is what the advantage here is. Anyway, goal. We want the x squared plus constant x plus, we need a little bit more, and then we have to subtract something else. And this is all still happening inside the square brackets. So that's this negative 7/2. It's still inside the square brackets because I haven't done anything yet. If I wanted it on the outside, I would have to, there's a way I could do that, but I'm just going to group it on the inside. But here, 1/2 of 3/2 is 3/4. So 1/2, and then to the second power. So that's like your calculator button. It's divided by 2, you get 3/4. That, you then evaluate that, you get 0.75. Square that, you get something else. That's 9/16 is the magic number that you add and subtract. And what do we have? We have -2 times x plus, well, we need not 3/2, we need 3/4. I think I'm gonna emphasize this, but it's not wrong, but let me just keep emphasizing this by making it green. So x plus 3/4 squared is the other green parentheses. X squared plus 3/2 x plus 9/16. We've got a minus, well, let's do a common denominator while we're at it. 8/8. Okay, so 9/16 minus 56/16, and those numbers are a little bit large, but okay. So that's 65/16. X, sorry, that's a plus 3/4 squared. That's completing the square, and then actually solving the equation is like a little bit of follow-up step. So now we can divide by -2 if we want. Okay, so if we take, so then plus or minus, and then square root of both sides. So x is -3/4 plus or minus. That's 16 is a 4. Is the square root of 16 is that's a 4 in the denominator. And then 65 is it's 5 times a prime number, I think. I'm pretty sure that's not gonna. I'm pretty sure you can't factor any squares out of that, because you factor out a 5, and then what are you left with? I think it's 13 times 5. So that you can't. No perfect squares here. It's just square root of 65 is square root of 65, and then that's the x that you get. All right, so that's kind of that's how you do it by completing the square, and we'll see a nice application of that in the next chapter. But let's go ahead and practice it one more. Pretty nice. I hate to erase it, but looks like everything's correct here. All right. I'm just like, every time I do something big, I'm so used to, my instinct is I would stop and ask for questions, but it's all crickets in here. It's okay, so let's make this a little bit. Yeah, let's do some different numbers here. So let's try 3x squared plus 6x and then minus yeah, something like that. That's fine. All right. So let's I'll use green again, I think. So, well, this one's nice because this one already has a 3 that you can factor out pretty easily. But this is, I want to factor out a 3, but 3 divided, do I have to use blue? I could use blue or I could just use black here. The thing I really want to emphasize is that the green thing is, there's a term that's a multiple of 3, another term that has that's a multiple of 3. They have to all have 3 in common, and if they don't have 3, you multiply and divide by 3 to put it there. And then once you've got a common factor, the whole thing becomes, or it can be grouped as 3 times something. So 3 times x squared plus, that one's factored out. We've got 2x minus 4/3. So maybe you can skip one step or here or there, but you can't skip too many steps. You want to, at least half of these, even if you're really, really good, you want to write down at least half of these steps, just whatever, how, okay, so there's a couple things that we have to check. I went pretty fast here. Let's make sure I did everything right. So all I did so far is I didn't even write down what the matching number is yet. I just took these brackets. They have to be in exactly the same place as they were before. We can't just forget that they're there. There's a 3 that this whole inside expression is being multiplied by, and that whole thing is equal to 0. Well, the magic number is we have, I guess have is the verb with a V. Anyway, we have it to get 1, and then we square it to get, maybe these numbers are a little bit too convenient, but we did a couple that were where the numbers were a little bit harder. We add 1 and we subtract 1. Okay, looks good. And what do we get? This thing in the green parentheses is now the square of something. It's not x plus 2 squared, it's x plus 1 squared, because we get twice 1x and 1x. So the half thing is it's x plus 1 squared. And we needed this other matching number here in order to balance that out. So that part is a perfect square. There's a negative 1 left over. Well, I already wrote it down. So there's a negative 1 and there's a minus 4/3. So that's negative 7/3. That's what we have there. So that's the completing the square part of the problem, but we said we actually wanted to solve for x. So we divide by 3. So we divide divided by 3. Well, it's the entire left-hand side is 3 times this square brackets. So the 3 is divided both sides, and the right-hand side is 0 divided by 3, which is 0. Plus or minus take positive or negative square root of both sides. X is -1 plus or minus square root of 7/3. And again, if MyLab is being really nitpicky about this, then okay, sure, X is -1 plus or minus, rationalize the denominator. It's the MyLab kind of prefers this standard form, -1 plus or minus 1/3 the square root of 21, something like that. On MyLab, like I'm not going to be able to send the FBI to your house to spy on you. I would never do that. If MyLab asks you to do it by completing the square, well, that's a good exercise, and you should probably do it that way, just to reinforce the knowledge. And it has applications that we're going to see in the next section. There's a lot of things that's cool about it. You should do it that way, but there's no way I can check, and I'm not gonna lose sleep over it. If you do it by the quadratic formula, and it's just the MyLab electronic test, and it's only asking you what's the solution, there's no way I'm ever gonna know. On the other hand, for the homework where I ask you to do it by hand and you turn it in, I'm gonna be looking at it, and everything is gonna be right there for me to see. I do want you to learn this, so I had you do it by hand, and I have had you turn it in. And when you do that, I'm going to see it, and if I say this, then I want to see your work written up, and if I say, and you have to show your work and all that. So on the homework, I'm serious about this, and I will be able to look at and see it. So that's why it's worth so many points. Sure, it's a little bit annoying. There are a few different steps here, but you'll be rewarded for it. It's definitely something you can do. Just sort of slow it down, and that's it. Just sort of figure it out. There are other videos on YouTube, but as long as it's the same process, and if you try some other process and it's basically completing the square and it's not the quadratic formula, how do you deal with the A? There's a slightly different way of doing it that's for this problem pretty valid. The way I just showed you has applications in other situations. That's why I'm doing it this way. But if I ask you to complete the square, there's like a couple of ways that are only just a little bit different, and you can use either one. I only showed you the way that I like to do it. But if I tell you to complete the square, complete the square. That's it. Let's see, am I forgetting anything? I think that's... I'm going to say something about the quadratic formula. So here is... Yeah, nobody was just born knowing the quadratic formula. That's just... well, it's just completing the square is kind of the little insight, and with a little bit of pattern recognition. Someone figured out the half and square trick. I think it was ancient Babylon. Is kind of the first surviving recorded history of someone solving this by completing the square is the cool trick that does it. Well, anyway, if I don't give you specific numbers, if I just call the letters A, B, or what if I do this? if I don't give you specific numbers, if I were to just give you A, B, and C, I'm not going to make you do this because the whole point is that this is really, really a pain. But this is how you get, if you do it and you just call them A, B, and C, and you never actually say what numbers are these exactly. If you sort of do it in absolute generality, well, here's my magic number. I take B over A and I have it and I square it, and it's, I get B squared over 4A squared, but then I have to subtract it as well, and blah, 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 blah. It's a lot of stuff. And then like 15 minutes later, quadratic formula. Well, okay, then there's still some work to be done. You do all exactly the same steps, but you write down the general case as you go along, and then pop goes the weasel. X is negative b plus or minus square root of b squared minus 4ac, all of that divided by 2a. I'm not going to make you do that, but it's good to know where these things come from. Nobody just, some magical chipmunk didn't just whisper the quadratic formula in somebody's ear while they were asleep and they woke up, just started knowing, and it just happened to work every time. That's absolutely not how it happened. What someone did is they stumbled on the half and square thing by sort of having that little insight, and then once you have the correct insight, you're halfway there, and you just have to do, and you just build little bridges between the individual steps, and then it all comes together, and it's very nice. So anyway, good luck on that. It's worth a lot of points. It should be worth kind of extra points. I hope you benefit from that rather than being harmed by it. Just make sure you actually do it. If you turn in late, there will be a penalty, but doing it a little bit late, if it really, really comes down to that, it's going to be a lot better than only doing half of the assignment. You can always check your answers. You plug your numbers into the original equation, and it's either equal or it's not. And if it's not, then you made a mistake and you have to try it again. So it's 100 points. So I hope we get it. So anyway, good luck.